Yeah, I think the biggest challenge is for utilities to integrate the distributed generation is the intermittency issue of solar and wind. And so the issue with the solar and wind in particular with that intermittency is when the output drops, the voltage likewise drops in that specific location. And so like the most difficult days to operate in, like here in Southern California, is a partly cloudy day. The cloud would come over and drop the output of that rooftop photovoltaic power, but also the voltage would likewise drop. And then when the cloud blows over, the voltage pops right back up as the power output comes back up. So that's causing disruption to the grid operators on being able to manage that intermittency. So because we are so heavily involved in big data and analytics, we are populating these network models with these granular rooftop photovoltaic models in our network operations. And so utilities can get a predictive indicator that something is going to happen, like the cloud is going to come over based on weather data that we're also integrating into our network model, and be able to give a predictive indicator to say maybe we need to prop the voltage up for a few minutes because we're expecting the cloud to come over and cause the voltage to drop, and that would keep us within the bandwidth of acceptable voltage criteria. The other thing is helping utilities understand what other kind of mitigation factors can be built into this, like the smart inverters that can do like dynamic voltage support. So the biggest issue here is this whole edge of the grid modeling, which is an exponential growth of data. And so that's been the limitation with some of the current technologies, is how do you integrate this large volume of data into these more complex network operation models and even planning models. That's the other piece of it, is now we need to change the way we think about how do we plan our systems to be able to support these types of issues. And so what we're doing is trying to help utilities be able to do more with renewables through these more complex models and using big data to help drive optimization. So the grid of the future, I believe, will be more of a platform, a plug-and-play platform, meaning no longer will it be a power delivery grid, meaning we have these central power plants and we transmit power through large transmission lines and through the distribution out to the end customer, but will be an interoperable platform, meaning customers will both be generators of energy through their rooftop photovoltaic, some storage, electric vehicle to grid options that utilities have. So I think what the grid of the future will be that platform that would be able to absorb power as well as deliver power based on what the consumer needs are. And so part of that is what we can do for utilities is providing more of this modeling capability for real-time operations, but also for planning and even looking at scenarios saying, what if we were 100% renewables? How can we support the grid if we went to 100% renewables? And so by having this more complex simulation tools, being able to integrate this edge of the grid data from these devices such as rooftop photovoltaic, smart meters, vehicles, those types of things, that we can have a much better understanding of how we can actually do that.